Hello everyone, it's Robo Theory, and I'm with my first video today. Today I'm going to be talking about the types of robots on certain fields. So I will be explaining the different types of robots on the field, and I will also quickly go over the skeleton of a robot, which will be explained in depth in my next video. So the four types of field areas. There are four types of field areas in which a robot can interact with and work on. It is hard for a robot to switch field areas, for example, flying in the air to underwater all of a sudden, but technology makes this transition more developed as the days pass on. So the four types of field areas are air, underwater, space, and ground. So aerial robots are, which is air, aerial robots are robots specified to move in the air. There are three types of aerial robots. AUAV, which is autonomous unmanned aerial vehicles, and basically the vehicle is unmanned, there's nobody inside, and the vehicle is also autonomous. So nobody's actually controlling it and nobody's actually inside. UAV, which is unmanned aerial vehicles, so nobody's inside of the vehicle, but it is being controlled from someone not inside. And RPA, which is remotely piloted aircrafts, which is basically when the aerial vehicle is being controlled from the inside of the actual robot. So, what are drones? Drones are UAV vehicles because someone is not inside the vehicle controlling it. Instead, the operator is on the ground or elsewhere controlling the drone. So we can relate UAV to drones. Next, let's talk about underwater vehicles. Underwater robots, well, vehicles and robots are kind of switch terms, so I'll switch between those terms every sometimes. So underwater robots are designed to handle high amounts of pressure. There are two types of underwater robots. AUV, which is autonomous underwater vehicles, and basically they're fully autonomous underwater vehicles, and ROV, which is remotely operated vehicles. This is kind of general, so it's basically when the vehicle is being controlled from the inside or outside by a human. And submarines are ROVs because they're being remotely operated vehicles from a person on the inside, or they can be on the outside maybe. So yeah, ROV. Yeah. So now let's talk about space robots. Space robots are complex. They must be able to withstand high amounts of speed and pressure because of the high amounts of speed and pressure they're actually moving at. And there are basically two types of space robots. Manned, which contain humans inside of the vehicle, and the human can control the robot from Earth or from the vehicle. Or unmanned, a robot autonomously moving because of preset programming in the scenario. Manned and unmanned are kind of general terms. I would say they're more of teleop and autonomous. So you can kind of say manned is teleop because somebody's controlling it, and unmanned is not teleop. And an example of a space robot is the ISS Robotic Arm, which is the International Space Station, and it's a space robot because it is in space and because it is controlled to complete certain tasks. So I know it's kind of blurry and half the picture's out, but on the left side of the picture, you would see an astronaut, and basically they're sitting there controlling the robot to do a certain task. For example, fixing the side of the International Space Station or doing anything else. So ground-based robots are the robots used in robotics competitions, heavy-duty work, serving meals to customers, and much, much more. I would say these robots are probably the most frequent robots that we see often. Just walking around, you could probably see a couple of robots in your house, and they might be for certain small little tasks. For example, iRoombas, which clean the house, or different types of robots. But they're ground robots because they're on the ground. These robots are more common than the other robots because of the simplicity of their terrain related to the other types. So aerial and underwater, you don't often see those types of robots. Well, maybe aerial, you might see drones a lot. But space robots, you don't often see them because they're mostly in space. You can rarely see them on the ground. And the types of ground robots are basically all the operation modes from the other categories combined. What this means is that, for example, you can combine different types. So, not combine different types, sorry. Instead, you can take different types of the, like, for example, go back, aerial robots and the underwater robots. We can take both of those types, and then we can just take all 5 of those and we can just put them for ground. For example, remotely piloted. Somebody's inside of the ground vehicle and controlling it. Somebody's outside. So ground is more of a general term, but yeah. And an example of ground that I've put is these robots are maneuvering around the ground and serving meals to customers, and they're also picking up dishes, which I think is really cool. And as we see on the left, they order the meal, and on the right, they would serve the meal. And now let's talk about the skeleton of a robot. So when building a robot, there's a basic skeleton comprised of 4 basic softwares and hardwares. So let's talk about those. As we can see, there's a microcontroller, and there are 2 arrows pointing toward the sensors and actuators, and both of those are pointing toward the end effectors. Those sound like big terms, but if we relate them to human body parts, for example, it'll sound much easier. Microcontroller. So the microcontroller is basically like the brain of a robot that assigns tasks and that have been delivered through code. And the microcontroller also takes in information to decide the next task. So for example, if it takes in certain data saying we're 150 meters from this certain place, then the if else statement would say slow down, you're about to reach the destination. So now sensors. Sensors are more of like how you feel, like you smell, sight, hearing, taste, and touch. All of those. So the sensors give away minute details of attention to the robot and deliver them to the microcontroller to receive the next step. So basically they're feeding information from the sensors all the way to the microcontroller to see what's next. And there are multiple types of sensors, as I've shown in a picture in one of my previous videos. And basically they're like thermal sensors. You can sense heat. So if you're getting close to for example, volcano terrain, you can sense a ton of heat and the terrain is more red and you feel all those sensors. So then the microcontroller will tell the whole robot to stop or just slow down, for example. And these sensors are really important. And for example, relating to a human, we have senses, our 5 senses, and as I'm talking through this video, you're listening through one of your senses. So you're taking that input and you're putting it through your brain, and your brain is telling you what to do next. Should you keep on listening? Should you exit this video? Or should you subscribe? Just kidding. But anyway, now let's talk about actuators. Actuators are like the motors that control the robot's hardware movements, and are normally assigned the tasks after sensor information is transmitted. So actuators are basically like those hardware motors that we see on a robot. And this could mean anything. Like, I would say motors are more of like your bones, but I would also say they're more of like your skeletal system. They basically help you move around. So these actuators is a fancy term for motors, and they basically, control the robot's hardware movements, so moving the wheels. So the sensor would take the information saying we're getting close to a volcano 150 meters. It would send it back to the microcontroller. Microcontroller would tell the actuators to slow down. So then the wheels would slow down. And now let's talk about the last one, the end effectors. Now the end effectors are basically the aftermath of the result of all the code due to the actions the robot made to change the environment. So it's basically like what happened after the end effectors. And the robots all go through the skeletal system of, well, basically cycle, I would say. And robots must go through the cycle to actually be successful and achieve something. So yeah. Well, thank you for watching this video, and remember to follow me on Instagram. Remember to subscribe and like this video, and if you have any questions, just add them in the comments. And also just put down there, if you have on a robotics team or program, just put down there your team number or team program. Okay, bye.